Guys, coming at you day 11 of virtual learning. I got a friend here. This is Luke. Say hi, Luke. Yeah. And, I don't know if you know, my life came to be a little crazy. My wife's an emergency room nurse, and so just getting things done today. There might be some interruptions, but I promise you I'll lay it out real well, and we'll take care of it. So we're going to dive a little deeper. Hey, come on, dude. Come on, dude. We're going to dive a little deeper into quadratics. We're going to be solving quadratics by isolating variables and by factoring. And what's really cool is, again, I know I always say this, but if you focus on concept, it all makes really good sense, and there's reasons these things work. So that's what we're going to focus on. Concepts. What we're doing, why we're doing it. All right, let's get after it. Okay, so here is a quadratic equation. One thing that's going to point you out to quadratic equations, like we talked to before, right there, that second power. And so the other thing to remember is quadratics are always going to be a parabola. So we're going to have parabolas opening up or opening down, and we're going to be, when we're solving, we're looking for the zeros or where they cross the x-axis, okay? And remember, they could cross in three different ways. They could cross the x-axis twice. They could cross it once by just touching it, and they could cross it no times, like if it just never gets to it. So we're going to be looking for where this crosses the axis. So like, what would the x variable be, or in this case, r variable? So to figure out what that is, in this case, we can just isolate the variable. So I'm going to undo times 12 by divide by 12. Then I'm left with r squared equals 1. And then I can take the square root to get rid of the square. And that'll give me this. So this is going to be, there's going to be two answers. 1 and -1. And so the reason there's two answers is, we're trying to figure out what r is. Well, 1 squared equals 1, and so does -1 squared. So we're going to have two answers for some of these. When we take the square root, there is always a positive and a negative answer to that square root. So really what that means is, in this equation, there are two answers that satisfy it for r, 1 and -1. And if you looked at, you can go on decimals and plug in this equation, you'll see right where it crosses. It crosses 1 and -1. So this one, we're going to solve for x, and we're going to divide both sides by 3. And 27 divided by 3 is 9. I can take the square root of both sides of this to get x is -3 and 3. It's both of those. All right, remember, -3 times -3 is 9, so is 3 times 3. And a check you can always do is you can always substitute these back into your original equation, and if it's the right answer, it'll work. If it's not the right answer, it won't. You could also type this into Desmos and see where it crosses the x-axis. Alright, so let's check this one out. To isolate x on this one, I would subtract 5 from both sides. X squared is 25. Take the square root to get rid of the square. So that is x is -5 and 5. So if you thought about what this looks like, and this isn't going to be perfect, I know that my x values would be 5 and -5. And so my parabola would look something like this, okay? I'm just throwing out a general look. So it's going to cross in these two places. That's what's happening there. And that's what our answer right here is saying. It crosses in those two places. So we've got one more kind of like that. Let's add 10 to both sides to get x squared alone. To undo the square, I take the square root. And I'm going to get my two answers, -6 and 6. All right. Cool. Feel free, guys. I know it's moving quick. I want to give you enough time on the homework and keep you in that 30-minute time frame. Remember also, you're getting weekly enrichment options. So I already put on Google Classroom an additional option for you, and that's using the quadratic formula, the formula itself. Normally we would have done that in the standard school year. So if you have some time and you're feeling like pushing yourself, I'd sign that too on Khan Academy. All right, so check this one. You might notice we can't really solve for x by just straight up like isolating, right? Because there's x twice. But we practiced already, one thing we practiced already is factoring. Now, Another thing I want to point out is, see how it's set equal to 0? That's because, as you remember our x-axis, wherever it crosses our x-axis, what does y equal? Y equals 0. So it's kind of like y equals all that, but we're going to slap a 0 in for there because on the x-axis, y equals 0. So really what we know is I'm looking for 2 points where the y value is 0, and that's going to be x. So that's why there's to solve a quadratic, there always needs to be set equal to a 0 because we're finding the x-intercepts. That's what it means to solve a quadratic. So I'm going to factor my trinomial into 2 binomials. And remember, we're going to see this third term, and factors of 6 would be 1, 6, 2, and 3. 1, 6, 2, and 3. And remember, the sum has to equal this middle term has to be the sum of those. So I'm going to be using the 2 and 3. All right, so there's my factored form, my 2 binomials. This is equivalent to my original equation. Notice it's set equal to 0. Now, there are 2 ways to get an answer of 0. And stay with concept with me on this, okay? Because it's going to look a little messy. Just stick with the concept with me. No matter what happens, I need to equal 0. So I'm going to look to get this whole term to equal 0, because 0 times this is 0, right? So if I can get x plus 2 to be 0, it'll work. Also, if I can get x plus 3 to equal 0, that'll work as well. So let me show you what I mean. If I can get this to be 0, I can get to be 0 if x is negative 2, right? Would you agree? Negative 2 plus 2 is 0. So x can be negative 2. And the reason that works is, if I have 0 here, 0 times x plus 3, whatever that is 0. 0 times anything is 0. So one way I satisfy this equation is by saying x is negative 2. I can also make this 0, and 0 times this equals 0. The way I make this 0 is by having that x be equal to negative 3. These are the 2 things that make this true. Either one makes it true. So my answer here would be x equals negative 2, negative 3. Oh, my kid's putting an electric toothbrush on the door. 1 sec. Hey, bud. Go play. Go play. Okay. So what would be happening here is a parabola would kind of like be crossing here at negative 2 and here at negative 3. So something like this. Thank you. Let's look at another one of those factoring. So, this one we're going to just fix it so I have 1 variable instead of 2. This one we're not going to factor into 2 binomials. We're just going to factor out a variable x. So when I factor out an x here, I'm left with x plus 3. So there's 2 ways I can get this to equal 0. If that x right there is 0, 0 times this stuff right here equals 0. That works. Also, if I can get this whole thing to equal 0, if that x is negative 3. If that x is negative 3, you can see x times 0 would equal 0. That also makes it true. That's why there's 2 answers. So this is one of those trinomials I can get to 2 binomials. I notice it adds to be negative but multiplies to be positive, so I'm going to need the 2 negative binomials. All right, and so I'm looking at factors of 4. I got 1, 4, 2, and 2. And the only way I'm going to get that to add to be negative 4 is the factors of 2. So I know my binomial would be something like x minus 2 times x minus 2 equals 0. It's equivalent. To get it, this one, do you notice that these are the same, I'm hoping? I don't need 2 of the same answer. So if this, my answer would just be x equals 2. And again, the reason that x equals 2 works is because if I slap a 2 in for that x, 2 minus 2 is 0, and 0 times anything, including 0, equals 0. Let's do another factoring. So remember, it has to be set equal to 0, because I'm trying to find the x when y is 0. Remember, when y is 0, that's our x-axis. So in this one, I know it multiplies to equal negative 28, so I need a positive and a negative. Factors of 28 are 1, 28, 2, 14, 4, 7. And so I need the difference to equal this middle term this time, 3. So I'm looking right there. and the larger one has to be positive to make plus. So I got positive 7, negative 4. And so the two ways I can make this equal 0 is if this number right here is negative 7, or if this number right here is 4. Those are my two answers. Either way, I get a 0 times something equals 0, or I get a 0 times something equals 0. That's why it works. If you focus on the why it works, it's so much easier than just like, if you focus on steps on this, it's like, why am I doing this? I can pump out answers. But we're trying to find when y is 0, and we can satisfy the equation with two different x's by making this whole thing 0. Whenever we multiply by 0, it equals 0. All right, I think this is the last one. Oh, two more for you? Two more for you. Okay, so on this one, I know it multiplies to be negative. That tells me one of each in my binomial. And I need factors of 21. So 1, 21, 3, and 7. I need to get a negative 4 from my middle term. So I'm going to be looking at those factors of 3 and 7. The negative has to be larger to add to equal negative 4. So there's my binomial times binomial. Remember, we did this the other day. Again, I need each thing to equal 0 because that'll satisfy it. So to make this binomial equal to 0, x can be negative 3. And to get this binomial to equal to 0, x can be 7. Those are my two x values that satisfy my equation. Now, you can always check this by substitution. You can substitute these values into our original equation. Let's just try that out. So negative 3 squared right here, that'd be 9. Negative 3 into there would give me 12. 9 and 12 is 21. 21 minus 21 is 0. So the negative 3 works. Let's do the 7. I put 7 here, I get 49 minus 28 minus 21. Well, that'd be a 49 minus 49 to equal 0. So check. Both those work in the original equation. And the reason I'm going to show you, let me show you why you want to be able to find these answers by factoring, friends. Because the other option you're going to learn, if you do the extension or you'll learn it next year, is the quadratic equation. And the quadratic is negative b plus or minus the square root of b squared minus 4ac over 2a. And this is coefficient a, b, c. And to do this, I'm not even going to do the whole thing. I'd have to do negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so I would have to simplify this, and the reason for the plus minus is the same, the two answers for the square root. This is way more work. With practice, you can look at this, factor in it, x minus 7, x plus 3, even in your head, and just write down x is 7 and negative 3. So I do these in my head through this process. There's no way you can do this in your head efficiently. So this is an efficiency thing for next year. Okay, so this one, one sec, I got another baby. What's up, man? Want to come out here? Okay. I'm almost done, Luke. So I want to show you on this one, equals, I meant this to be 11, not negative 11. No, I meant it would be a negative 11 and a minus 2. Let me fix that up for you. You won't have one on this homework. Okay, so I add 2 to both sides. X squared equals negative 9. So you'll try to take a square root, but what you'll notice is you can't get anything times itself to equal that negative 9. So remember we talked about those parabolas that never touch the x-axis? This is going to be no solution. It's never going to cross the x. And I know that because I can't take the square root of a negative. Alright? Cool. Thanks for watching, guys. Make sure you're reading all the directions when I'm posting stuff, communicating well through email. You need something, I got your back, alright? Wednesday, 3:30 to 4:30 office hours again. Hope to see you there.